most valued student. My name is Confident. Welcome to our revision session. And in actual fact, this lesson, it covers different grades and levels. I will suggest it for grade 11 and grade 12, as well as those who are doing their N3 and N4. So this is a lesson on trigonometry, and it lays a foundation that is most important for you to be able to understand trigonometry. After this lesson and the lessons that are to come, so this is part 1, I will do some other parts depending on how long this lesson is. I just want to make it as short and easy to understand as possible. So as I said, it's for those who are doing their grade 11, their grade 12, and those who are doing their N3 and N4. So what I want to do is lay the basic foundation that will enable you to understand the trig in all its aspects. And believe me, after this lesson, you'll be able to understand the whole section on trigonometry, which is troubling a lot of students. Now, I'm going to go slowly throughout the lesson. I'm not going to rush, but I want you to take time to view all these lessons, and after that, check out your performance on trigonometry and you will see that it is improved. That I promise you. But now let us look at the beginning, or what I can call the foundation of most of the trigonometric challenges that we are facing. It is based on the cast diagram. Now, when we are talking about the cast diagram, what am I talking about? So this is what you'll be having when you're talking about the cast diagram. I'm just going to draw it here to say, and I'll always encourage you to have your cast diagram handy whenever you are dealing with this what I call your maths trig. So this is what we have. We have got our I will call the quadrant. So what we have here, we have the beginning. This is quadrant. This is 0 degrees. Now in trigonometry we move anti-clockwise, so this is the direction that we move. As you can see, we are opposing the clock, so this is the normal way of moving. So we move from 0 and then we go to 90 degrees. From 90 degrees we go to 180 degrees. From 180 degrees we go to 270 degrees. And from 270 degrees we return back to where we started from, which is now 360 degrees. We call that a complete cycle or a complete revolution. So this is how we're moving. Remember the direction. We oppose the clock and we say it's anti-clockwise. Now the first part is which quadrant is which. We have the first quadrant being here, and then we have the second quadrant, and we have the third quadrant, and we have the fourth quadrant. So these are the first thing that you need to know. And as I said, it is called the cast diagram, but I prefer to use the words all students take chemistry. So the all, it starts from here to say A means all, S means students, T means tech, and C means chemistry. So all students take chemistry. But I think you can see the word cast, it starts from here, from 1, 2, this is 3, and 4. You can see that word formed is C-A-S-T. That's why they call it the cast diagram. I think you can see that. So that word C-A, from here to say C-A-S-T is called the cast diagram. But now most of the students, if you just say draw the cast diagram, what they usually do, they start their C from the first quadrant, which makes them more confused and everything wrong. So what do I usually use? I use the words all students take chemistry. So I use the first letters. All is A, students start with S, tech start with T, and chemistry start with C. Some they say coffee. I prefer to say chemistry. So this is what we are having, as I said. Now, with this CAS diagram, I then have to write the reduction rules that are applicable in each quadrant. So in quadrant number 1, the reduction rule, as you can see, is between 0 and 90 degrees. So the reduction rule that is applicable, I will talk about what that word reduction means. It is 90 minus theta. So it's 90 degrees minus theta. This is the reduction rule that is applicable to quadrant number 1. In quadrant number 2, the reduction rule that is applicable, we have 90, because we have already passed 90 degrees. So it's after 90. So it's 90 plus theta. But at the same time, we have not passed 180. So we are before 180. Now the second one is, because we have not passed 180, so it is 180 minus theta. So these two are in quadrant number 2, and most of the problems actually emanate from this quadrant, which we're going to discuss as we continue. Now, in the third quadrant, the reduction rule is we have already passed 180, so it's after 180, but we have not yet passed 270 degrees. Because it's after 180, it is 180 degrees plus theta. So for now, don't use 270 in your reduction rule. We're going to deal only with 90 and 180. And the last one is, because we have not passed 360, so it will be 360 minus theta. So these are the reduction rules that I want to focus on whenever we're dealing with this CAS diagram. So as I said, the first one, you just need to know how to come up with this diagram as I've drawn it. So whenever you're doing your trig, quickly take your pencil in some rough paper. Just try to write everything I've done. It just take you 2 minutes, you'll be done, because it helps you to solve most of your trigonometric questions that you'll be having. So when you have done that, the other information that is important is to understand your trig ratios. Now, our trig ratios, we've got 3 trig ratios. We have sine theta, we have cos theta, and we have tan theta. Now, when they say all, A means all. So that word all means all are positive. That's what it means. And then in the second quadrant, we have got S. And I write them again. We've got sine theta. We have cos theta. And we have tan theta. Of these, you can see S, it means only S is positive, the rest are negative. So that is the only part why it says S, because here it's only S that is positive. And the next one that we have is quadrant number 3. And again, if I can write the trig ratios, we have got sine theta, cos theta, and we have got tan theta. Now, because we have got T, you can see that we've got T, it means only 10 is positive, the rest are negative. Hence, we have that as T. And lastly, I think now you can see it, we have in this fourth quadrant, we have sine theta, cos theta, and tan theta, and we have cos, meaning only cos is positive, the other two they are negative, and that's why we call it C. So that's what we are having. So this is what we have as the most of the information. As I said, when I'm dealing with the CAS diagram, you are dealing with this information. Now, how does this information in some way come handy? Now, let us look at it from this perspective, and I'll just bring you a few examples that we're going to be using, and it will be relying on this information that I've just drawn here. Actually, maybe I use a new page. Let's do this. Leave it here. Then let me use a new page. So Let's look at an example of these reduction rules. Suppose they say we need to simplify, for example, cos. They say simplify the following without a calculator. So they want us to simplify the following, and remember, no calculator in this case. So now I'm going to use a few examples that we're going to have, and this is where reduction rules come in place. So let's look at the first question. For example, we are looking at cos 120 degrees. We are supposed to simplify that without using a calculator, but as I always tell students, when they say don't use a calculator, the first thing you need to do is to take a calculator and check what is the answer that you get for that. So cos 120, it gives us negative half. So I will keep in mind my answer being equal to, here, equal to minus 1 over 2. I'm just keeping it in mind just to know that I'm working towards that. But now let us prove how did the calculator get negative half. So when they're giving me cos 120, the first thing I need to identify is where do I find 120? In other words, I'm asking myself which quadrant is 120. So when I go backwards and looking at my cast diagram, now 120 lies in, it's after 90 degrees because it's 120, it's after 90, but it's before 180. So 120 lies in quadrant number 2. So that is where you're going to find 120 degrees. You agree, right? So this is where I will locate my 120 degrees. It is after 90, but it is before 180. Now the next question I'm going to ask myself is, what is the reduction rule in that particular quadrant? So the reduction rule in this particular quadrant is these two, 90 plus theta and 180 minus theta. For now, I'm not going to focus on 90. I'm just going to focus on 180 minus theta and also 180 plus theta as well as 360 minus theta. The other lesson, I'm going to focus on the 90 plus theta. So because 120 is found in the second quadrant, I'm going to use 180 minus theta. So my answer is going to be cos, in this case, cos 120 degrees is equal to cos. Now I write the reduction rule in brackets. So it is 180 minus theta. Remember? But now the question is, what do I put in space of theta? So what we are saying is, which number must I subtract from 180 in order to get 120? So what you simply do is, you take a calculator and subtract 180 minus 120. It gives you 60 degrees. So if I subtract 60 degrees, that is my theta here. If I subtract 60 degrees from 180 degrees, it will be 120. You can test that with the calculator and say 180 minus 60. See that? What does it give me? It gives me 120. So which means I didn't change anything, but I've used the reduction rule of the second quadrant, which is 180 minus theta. And I'm going to use that reduction rule to reduce. And what am I reducing? I'm going to reduce this cos. That is the first question I'm asking myself. The second question I'm going to ask myself is, in this particular quadrant, which is quadrant number 2, what is the sign for cos? And you can see that the sign for cos is negative, because in quadrant number 2, according to the cast diagram, cos is negative. So I'm going to then write my answer as minus cos. And after that, you write that particular angle that you used as you the reduction. In the reduction part here, there is an angle that you found when you subtracted. That is the angle that you're going to use. So which becomes minus cos 60. So the final answer therefore is negative cos 60. This is what we mean when we say reduce cos 120 degrees, and when you reduce it, it gives you negative cos 60. You can test it with your calculator and say cos 120. Remember, it gave us a negative half. Now minus cos 60, it's also giving us negative half. You can see that we have managed to reduce cos 120 into cos 60. Now what did we do? We took cos 120 and we reduced it into the first quadrant, and the first quadrant, that's where we find 60. That is what the cast diagram is doing. It is going to reduce the second quadrant into first, the third quadrant into first, and the fourth quadrant into first quadrant. That is actually what we are doing whenever we're using the reduction rules. That's why it's called reduction, so that we reduce these. All right, having done that, let us look at another example that can come in handy. If for example I'm given let's say let me use another one, sine, in this case sine 300. Now the first question I ask myself is, by the way, use your calculator to find what is sine 300, and sine 300 is equal to negative root 3 over 2. So you can have that quickly to say this is negative square root of 3 over 2. But now let's prove that with our normal working. Now the first thing that you ask yourself is, where do I locate 300 degrees? Now 300 degrees is not in the first quadrant, it's not in the second quadrant, 300 is not in the third quadrant, because you can see third quadrant is up to 270, but it is in the fourth quadrant because that's where we have 360. So what you do is you're locating your 300 here, and you ask yourself, what is the reduction rule of 300? It is 360 minus theta. So what you do, you come here and you say this is same as sine. So sine 300 is equal to sine, then you write the reduction rule that you have, which is 360 minus theta. But remember, you don't write theta just like that. There must be an angle for that particular theta. So what you do is you are subtracting 360 minus 300 so that you can get that angle. So if you say 360 minus 300, it gives us 60 degrees. So which means instead of theta here, we are going to have instead 60 degrees. So when you do that, this will be equal to, now the final answer you write, it will be sine, and you write that particular angle that you got for reducing, which will be sine 60. The next part is ask about the sine. You go backwards and say, what is the sine for sine 300? You can see that cos is the only positive, but sine is negative. So what you do is you are going then to conclude that your answer is negative sine 60. So now if you use a calculator to test your answer, you are going to now say sine 60 is actually negative sine 60, and then you check what answer you get. You see, you are getting negative root 3 over 2, which is still the same answer that we got in that. So which means you have reduced sine 300 or sin 300 degrees becomes negative sine 60. This is what we mean when we say use the reduction rule to simplify that. Now lastly, another example that you can use, for example in this case, is to say, let me choose another example, is for example tan 480. So what you do here, you're given tan 480 degrees. Now first thing first, what you need to ask yourself is, where can I locate 480? If you go in the cast diagram here, you will agree with me that the maximum that we can get is 360. That is a complete revolution. So what you do is you need to subtract 360 from 480. So it will be 10 480 degrees minus 360, which is a complete revolution. So it means you have returned to where you started from. In this case, from 0 to 360, we return to where you started from. So when you subtract that, 480 minus 360, it gives us 120. So what we have now is 10 120, and 10 120 is within our quadrant. So now we are going to reduce 10 120 degrees, and the first thing that you need to ask yourself, again back to our diagram, our cast diagram, is to ask ourselves, where can I locate 120? And we did say 120 was in this particular quadrant, which is quadrant number 2. So now the next thing you have to ask yourself is, what is the reduction rule of quadrant number 2? It is 180 minus theta, remember. So when you use that, come here and say this is the same as 10 180 minus, now your theta is as good as subtracting 180 minus 120, which is 60 degrees. So it will be 60 degrees in this case. And when you reduce it, you write that particular angle as the final, which is 60 degrees. But don't forget, you need first to tell us the sign of 10 in that quadrant, and you can see that the sign of 10 is negative in quadrant number 2. So what you do is you are going to then have your answer as equal to negative 1060. So that's what you have. Then you can conclude and say, therefore 10 480 degrees is equal to minus 1060. You can test it again with the calculator and say 10 480 degrees. You see it's giving us negative root 3. Now what about negative 1060? It's also giving me negative root 3. So you can see that the cast diagram is a way of assisting you to simplify bigger angles which are bigger than 90 degrees. That's what it's doing. So what you're doing is you are taking angles which are bigger than 90 degrees, like in quadrant 2 it's bigger than 90 degrees, in quadrant 3 it's bigger than 90 degrees, and as well as in quadrant 4. So you are taking these big angles, you are making them into quadrant 1, So what these angles are saying is reduce us from bigger sizes into acute. We call quadrant 1 acute angles. So that is basically what you are doing whenever you are reducing. So I hope this was a kind of a foundation. As I said, I'm just laying a foundation of the cast diagram. Join me again in the second lesson, whereby I will begin from this particular diagram going forward as a way of showing you how does this then become, how does this work further into your trigonometric questions. We have come to the end of our lesson. Thank you.